Hello everyone. We are Team 8 members, Subin Kim, Shinung On, Hikyong On, and Song Bapong. We're gonna talk about our third SRS presentation. Our topic was Total Healthcare Platform for Patients based on real-time monitoring with FMCW layer. And these are our contents. We divided it into two parts, system overview and system design. In system overview, there are two parts, requirements and tasks. In system design, there are 5 parts: system architecture, class diagram, user interface design, use case diagram, and description, and sequence diagram. There are 2 parts in system overview, and the first one is requirements. Firstly, we searched functional requirements from our 7 user cases: login, registration, user matching between caregiver and patient, and daily healthcare with checklist, an emergency situation, and added medical information of patient and real-time monitoring. And finally, we got 18 functional requirements from these. And next one is non-functional requirements, and we got this from 6 categories: development environment, internet speed for communication, bug and error control, connection between sensor, security environment, right input from users. And we finally got 19 non-functional requirements from these. And next, we divided tasks to 14 hierarchical groups. There are several tiny tasks below those groups. And first 6 ones are related to non-functional requirements. These are related to fundamental building for fundamental environment for platform and conditions for operating system in device without problems. And rest 8 tasks are related to functional requirements. These are for make full functions of our platform.
Our system architecture can be classified into 3 main layers: presentation layer, business layer, and database layer. Presentation layer is a set of features available on the user interface screen. In case of our system, there are real-time monitoring, emergency information, medical information, check health records, my page, and login and logout. These functions exchange information with the user database. Next, the business layer is the core set of tools and service in the system, including the emergency situation system, edit medical information, daily healthcare, users match, login registration, and these features interact with FMCW radar sensors to assist in real-time monitoring. Finally, a database layer represents a comprehensive database, the user database, which is the basis for the system to operate. Next, we will talk about classes that are components of the class diagram of the system. Class user is main class to organize users using the service. Includes ID, password, and class user info, which is a class for basic user information. It has 3 functions: login, get user, and edit request. Class user info is information about users type, patients and caregiver, email, birth date, address, phone number, connection. Such identification is needed to classify users and organize user database. It has update user info function. Class patients is subtypes of user, contains variable caregiver if there is a matched caregiver. And class caregiver is also subtypes of user, contains variable patient if there is a matched patient. Class register is a class for user registration. It has 2 functions: create account and check valid SSN. Class user match is class that used for matching patient and caregiver, and it has find user function and match user function. Class medical info is information about users' medical information working as the main class along with user info class. It has 5 functions: send medical info, update medical info, request checklist, find checklist, and get medical info. Class blood type is for blood type, and this class is included in class medical info. and it has compare b-type function. Class disease is for disease of the patient. This class is included in class medical info. Class checklist is class included in class medical info, and it has three functions: send checklist, grade checklist, and notify checklist. Class hospital info is for hospital class. This class is included in class medical info and includes the name of the hospital, phone number, and address. Class real-time movement is for monitoring to user in real time with FMCW later. Includes three main status, which is safe, absence, emergency. Also includes variable raw data, which is raw data received from FMCW later. Variable rescue shows whether the user is being rescued in emergency situation. And it has three functions: monitor FMCW and classify status, get state. Class emergency is class when an emergency situation happens. It has five functions: find hospital, call rescue, notify user state, send alarm, and send hospital info. The class diagram of our system is as below.
Hello, I'm Hyung-an. I'm going to introduce mock-up design of user interface. First, login page. This page is the first page the user sees. Users can log in by entering a valid ID and password. Right picture is mock-up design of main page. If login is successful, the main page appears. The buttons of frequently used functions such as real-time monitoring, check emergency information, check medical information, and healthcare checklist will be largely arranged on the main page to improve convenience. On this main page, if users click the real-time monitoring button, then that left screen appears. The color was used to make it easier to check state of patient. And users can check the records for the last 12 hours. Next, on the main page, as you see in the previous slide, if your users click the healthcare checklist and fill out checklist button, then user can fill out checklist. Users just answer the simple questions with yes or no. Lastly, on the main page, if users click the check medical information button, users can check medical information of the patient. And then, if users click the Edit Medical Information button, a page like the one appears. Users can select blood type and write down disease of patient on this page. Next, use case diagram. Red part is refined part from project 2. First use case is login. The user input ID and password. If ID and password is valid, the user log in to the system successfully. After login, the user can log out. Second use case is registration. The user asks the system to create a new account. The user's details are verified using the SSO authentication, and the ID and password of the user is verified. Then the new account is created with verified ID and password. Next is user matching. First, find the patient by birthday and name. Then system send acceptance request to the patient. The patient can reject or accept. Only if the caregiver is accepted, he or she can get the access of the patient information in database. Now, emergency situation use case. If state of the patient is emergency, send the emergency alarm to the caregiver. Find the medical information of the patient. Then send the rescue request to the hospital and the medical information of the patient. After that, send the matched hospital information to the caregiver. At this time, if the caregiver asks to check the rescue situation, the system receives movement data from FMCW radar. Then system classify the rescue state, rescued or waiting. Then send the rescue state to the caregiver. Daily healthcare with checklist. The user asks the system for a healthcare checklist. Then the user answers all of the questions in the checklist and submit it to our system. The system evaluates the checklist by criteria stored in the database. The system sends the result back to the user in display. If the user wants to edit medical information of patient, user have to click Edit Medical Information on the Medical Information check page in the app. User edit the registered medical information, then click the Save button. After that, the system stores the new medical information in the user database. Final use case is real-time monitoring. If clicks real-time monitoring button in app, user can check patient real-time state, either safe, emergency, or absence. In this process, the FMCW radar transmit movement data, and our system classify it into 3 states. And then user database receives that classified state and store. That classified state is received to user.
Next, I'll explain about sequence diagrams. This is a sequence diagram for login and registration. In registration, the user requests for creation of account if they are not registered to the platform. The platform checks the validity of the given social security number of the user and the ID password. If the social security number is valid, platform creates account and stores it in the user database. For login, the user would request for login by sending ID and password to the platform. The platform verifies the ID password with the user stored in user database, and if it is valid, the login would success. Otherwise, login would fail. Second, this is the sequence diagram for user's match. The user, which is the caregiver, requests for authority over a certain patient by sending ID email of the patient to the platform. The platform finds the matching patient from the user database, and if the patient is found, the platform asks the patient for acceptance of the caregiver's request. If the patient accepts, the caregiver and patient is matched, and the platform updates this information to the user database. This is a sequence diagram for daily healthcare checklist. First, the patient requests for checklist by sending his or her ID and the type of checklist he or she wishes to the platform. The platform finds the required checklist from user database and returns it to the patient. Then, the patient enters the checklist and sends the response back to the platform, and the platform verifies and grades the checklist. The platform stores the result in the user database and returns the result to the patient through email. Next is the sequence diagram for emergency situation. The emergency situation is triggered when the state of the patient is clarified as emergency. The platform sends an alarm to the caregiver, and it calls nearby hospital or rescue services for emergency along with the patient's medical information. The platform continues to check the patient's state to clarify the patient's rescue state and sends it to the caregiver. This is a sequence diagram for editing medical information. The user, which is a patient, requests to edit his or her information. The platform returns edit page to the patient, and the patient sends medical information that should be modified to the platform. If the information is valid, the platform updates the information in the user database. This continues until the patient has nothing else to modify. Last but not least, this is a sequence diagram for real-time monitoring. The patient requests to get his or her current state to the platform. This is automatically done once the patient is registered for monitoring in the system, which is the platform. The platform requests for real-time monitor data from FMCW radar and retrieves raw data. The platform clarifies the raw data and turns it into class real-time movement. The platform updates the information to the user database and sends the result to the patient. This was the presentation of Team8. Thank you for listening.